Now, these are examples of exponential functions. And in an exponential function, x is part of the exponent. Okay? So what we're going to do is plug in values here. So when x is -3, this equals 1 over 8. And just for the sake of time, the period is short, I'll just do it for you. This is 1 over 4. This is 1 over 2. This is 1. When x is 1, it's 2, right? When x is 2, it's 4. When x is 3, it's 8. Okay. Now, do you notice, let's do y equals 1/2 to the x, because these kind of match up. Do you notice that this is the same as y equals 1/2? Sorry, that's the same as y equals 2 to the negative x, right? You just reciprocate it, and that is equal to 1 over 2 to the x. When you reciprocate it, you get the exponent on x becomes positive. He doesn't know what? Do you have your book? Okay. All right. So here, this is to the -3. With the negative exponent, you move it across the division line, and it becomes 2 to the 3. So this is 8. This becomes 2 to the positive 2, 4. This is 2, 1, 1/2, 1/4, 1 over 8. So far, so good? So when we look at this, before I do move on, this is a reflection of this in which axes? When x is negative, what axes are we reflecting across? Y-axis. And you'll notice that when we graph them. Let's do 3. We're not going to do 5 because it's just redundant. Okay, 3 to the -3 is 1 over 27. 3 to the -2 is 1 over 9. 3 to the -1 is 1 over 3. 3 to the 0 is 1. 3 to the 1 is 3. 3 to the 2 is 9. 3 to the 3 is 27. Now, this one, 1 over 3 to the -3 is 27, right? Because this is equal to 3 to the positive 3. This is going to be 9, 3, 1. Now, 1/3 to the 1 is 1/3. 1/3 to the 2 is 1 over 9, and that's 1 over 27. Let's graph these, and we're going to notice some common characteristics of exponential functions. These are your parent functions, and we're going to transform these later. Okay, so let's graph y equals 2 to the x. So 0, 2, when x is 2, y is 4, when x is 3, y is 8. 1, 2, 3, 4, 5, 6, 7. Sorry. And x is -1, it's a half. So it looks something. If I go 2 to the exponent 4, I don't know, let's see. 2 to the exponent 4, we get 16, right? Might as well draw it if we can. It helps us out. Good? That's y equals 2 to the x. Let's now draw y equals 1/2 to the x, which is the same as 2 to the minus x. So when x is -3, we get an 8. 1, 2, 3, 1, 2, 3, 4. No, yeah, 1, 2, 3. Do you notice the reflection in the y-axis? And then 8, 9, 10, 11, 12, 13, 14, 15, 16. When x is -2, it's 4. When x is -1, it's 2, 0. Do you notice this is y equals 1 over 2 to the x, which is really the reflection in the y-axis. Sure. Let me know when you've caught up. You're caught up? Is everybody caught up? You okay, Alan? You're caught up? Everybody's caught up? No? Okay. Not an issue? All right. All right, so here we go. Will this graph ever cross the x-axis? So we have an asymptote. And notice it always goes through the point 0, 1. Let's do the 3 now. Okay, when x is 0, y is 1. When x is 1, y is 3. 1, 2, 3. When x is 2, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And when x is 3, it's 27, but that will go off the grid. It comes down here, and here it's a little closer than the other graph, but not quite touching. And then the other one, this is y equals 3 to the x. Let's do 1 over 3 to the x. It's just a reflection in the y-axis. Oh no. So it'll be something looks funny. Something looks funny. Okay, so let's do one is a series of transformations. I'll do an example with mapping, and then we'll call it a day, and I can tell you your mark. Oh, sure, I'm sorry. Birthday boy. Okay. Okay, let's do it. So if we don't forget to put your arrows on, there should be arrows to indicate they go on infinitely. that the axes go on infinitely. Let's look at this. When you look at this, what's the first graph you draw? What is the parent? What is the parent in this situation? Perfect. Y equals 2 to the x. So when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. When x is negative 1, it's a half, then a quarter. It gets closer and closer to the x-axis, but never touches. What's the next graph? That is number 1. What's the next graph we're going to graph? So it's minus 2 to the x. So this gets reflected down there. This gets reflected down there. 4, 5, 6, 7, 8. That's graph number 2. I'm going to change colors, change it up a bit. So now we can do the transformations. So we go left 3, down 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Ah! 1 goes off the graph. That's okay. Let's do this guy. 1, 2, 3. 1, 2, 3, 4. Okay. Can you tell me what the asymptote will be? I'm drawing the asymptote as I asked that question. So the asymptote is y equals negative 4. And now we can draw in our final graph. It will never, it gets closer and closer to the asymptote but never touches. See how I'm always showing key points? Do you need another example? Let's do mapping. Sure, we're going to do number 6. Okay, next. Oh, we didn't describe and state the domain and range. Let's do that right now. Okay, the domain. What can x be? X can be anything, any is in the set of real numbers. And what's our range? Y such that y is less than 0. Oh, I'm sorry. I don't know where that came from. I started thinking about something. And then I got distracted. So let's describe them. Description of transformations. 1. Reflection over x-axis. 2. Horizontal translation left 3. 3. Vertical translation down 4. Can you see it's exactly the same as the last unit? Good? Are we good? Okay, using the fact that the point x, y in the graph of y equals f of x becomes this point on the graph of a f of this, graph this. So this is where we graph in one step. Okay, I don't think I should have wrote over here. I need absolute. Oh, excuse me. Do you mind take? Thank you. We need some space here. We need to make tables. Okay, so we have, first we'll do our parent. We'll get a table of values for our parent function, which is 1/3 to the x. Then we're going to do our transform function. So notice a equals -1, k equals 1, d equals 3, c equals 4. So we plug it into this. X over 1 is x plus 3. So this is going to be xy of our parent function, and this is going to be xy plus 3 and -y plus 4 of our transform function. Should be plus 4. I just plugged it into this. So x divided by 1 is x plus d, which is 3. So this is confusing. This should be d and that should be c. The old textbooks used to use those other letters, but ay, so -1 times y plus 4. I'm sorry, this is a little bit messy. So let's find some points on our original function. So this is when x is -3, y is 27, -2, y is 9, -1, y is 3, 0, 1. When x is 1, 2, 3. 3 is 1 over 27. So now we have to sub in our x. This point becomes 0. Uh-oh. Something's funny. Did I make a mistake? Oh. It should be plus 6, right? This should be plus 6. That would have been a big boo-boo. Okay, -3 plus 6 is 3. -27 plus 4 is -23. It'll go off our grid anyway. -2 plus 6 is 4. -9 plus 4 is -5. And I'm always going to double check. -1 plus 6 is 5. -3 plus 4 is 1. 0 plus 6 is 6. -1 plus 4 is 3. 1 plus 6 is 7. 2 plus 6 is 8. 3 plus 6 is 9. So we've got that. 3, 4, 5, 6. Okay, now 1/3. 4 minus 1/3 is 3 and 2/3. 4 minus 1 over 9 is 3 and 8 over 9. And 4 minus 1 over 27 is 3 and 26 over 27. Ah. I'll just try to fix that. That should be at 27. Maybe I should take this off and then I can see how much paper I actually have left. That's a 26 over 20. Anyway, we don't need that much accuracy. That's our x. So let's graph the final graph in a single step. We're going to label the asymptote, label all graphs, and state domain and range. So 3, negative 23 is off the grid. 4, 1, 2, 3, 4, negative 5, 1, 2, 3, 4, 5 is there. 5, 1, 1, 2, 3, 4, 5, 1. 6, 3, 1, 2, 3. 7 is 3 and 2/3. 8 is, oh, it's getting closer and closer. Anybody know what the asymptote is? Y equals 4. Remember, an asymptote is a line, so you have to say y equals 4. That's our asymptote. So it gets closer and closer but never touches. So this is our graph. We'll just label it y equals negative 1/3 x minus 6 plus 4. Label state domain and range. Domain is x such that it can be anything, right? And our range is y such that y is less than 4, y is the element of real. Please get comfortable with this. Do you need another one? Huh? You guys will practice? Does you need this?